Okay, let's just finally fought with the IT equipment. Let's just finishing off this as quickly as possible. Functions. Seen a couple of functions already. Max, the aggregate functions, standard aggregate functions for getting the maximum, the average, minimum values of numeric fields. There are many more functions available in Postgres, come shipped with Postgres, come shipped with the extensions to Postgres. Not going to go through them in any detail except that show you one or two of them and so that you know where they are. So sorry about the quality of this, it's not quite as good a projector as in the other room, and this doesn't seem to go down any further. But here, this example, select name, you might need to read the PowerPoints rather than read what's on the screen. We are using the car length function, char_length, and then we pass in a field, and that gives us the number of characters in a text field. So this is an example of a text function, and as we can see, basically we're getting the number of letters in each city name. And in this case, we've also put a condition, so we're only returning city names with a length with more than 5 characters. Okay, so you want to do some text processing, which is quite a common thing. You've got latitudes and longitudes mixed up together in the same field, things like that. You may want to use the character string functions to sort those out. So there are lots of those. Look them up. Here's another one, just to give you another example. This is the left function, again on a string. The left will give you so many characters from the left-hand side of the string. So in this case, so in the first one, just took the name, a field as an input, because it was just the length of the field. There were no parameters or arguments passed in. The left is an example of one which you can also pass in additional parameters. So you've not only got to pass in the name of the field, which is actually called name in this case, but also after the comma, you've got an argument, which is the number of characters to return. So in this case, we're just returning 2 characters. So these are the first 2 characters in the value in each field. Concatenation. Concatenation is where you combine things together, strings together. Very useful function. And in Postgres, you do it with the double pipe. The pipe, this is the pipe key. If you don't know, not familiar with the pipe key, vertical arrow. Although on a keyboard, it often has a little break in it. So if we look at this keyboard, where's the pipe? The pipe is above the slash on the left-hand side, and it has a break in it here on the keyboard for some reason, but you type it into the computer and it's a complete line. And this is 2 pipes next to each other, and that will join text together. So here, maybe I'm writing out some kind of address or something like that. So I've got the city name. I've then concatenated a comma and a space. So I've added a space, a comma, then a space onto that city name. Then I've added the region, then another comma and a space. And then I've added the country name. But in this case, I've applied another text function, upper, which converts all to uppercase. So here we are, Kabul, Southern and Central Asia, Afghanistan. So you can see you've got the ability there to sort of build up a customized address function or whatever else you want. So that's all right. And that's obviously being drawn from 2 different tables, hence we've got a join function in there as well. You sometimes, once queries get more and more complicated, it's sometimes a good idea to break them down into subcomponents to make it easier to complete the query. As I say, there's many ways to write queries. Sometimes it's handy to have a subquery, write half of it as a subquery, and then call that subquery from another query. Okay, this is again rather a sort of toy example, but it's the principle that matters. Countries in which one language is spoken. Okay, there's a field in the country language with a percent, which is the percentage of the population that speaks one language. So technically, I guess it's not countries in which one language is spoken, but countries in which all people speak one language, at least one language. That's a better way of phrasing what that query is actually interested in. So if I want to get the countries in which one language is spoken, or in which everyone speaks one language, that's more correct, then I can do select country code from country language where percent equals 100. It's not that people don't speak other languages, it's just that everybody, or near as much, 100% speaks one language. Now, if I want to actually get the country names as opposed to the country codes, then I could do that with a join. I could get that result by doing a join between country and country language. And we know how to do that. But here's an alternative. It's a bit more long-winded, and it's not a sensible way of doing such a little query, but it demonstrates the principle. So here, instead of doing a join, what I've got is my select query which returns the country code, and then what I do is use an in clause that looks for, and then so I embed that within another select query, and that select query is just selecting the name from country, and where the code is in the results returned by this subquery. Okay, so this subquery returns me the country codes as a sort of array, a list of country codes, and then the in function for the select statement looks for the country code that is in that list returned by that embedded subquery. Okay? So you could do that with a join, more sensible to do with it on a join, but you can do it this way as well. A bit long-winded, but as your queries get bigger and bigger and more complicated, there are certain times where this in is really useful. And indeed, there's certain types of question where you have to use subqueries to be able to get the right answer. Okay, so that's pretty much the select statement. So there's just a few little oddities here to finish off. Deleting and inserting. So we've done bulk load with text files. But what happens if you actually want to, you've got a data error, you've seen some of the odd codes and things like hyphens where there's no district, that kind of stuff. Maybe you don't want a hyphen where there's no district, you'd rather have a null. So how do you go about updating and deleting records on an individual or group basis? Well, here's a little query, select star from city where name equals Dundee. So that's the record in the database for the city of Dundee. Okay, so I want to delete that record. So I can simply do delete from city where name equals Dundee. Why did I look at that record to start with? Well, because yesterday when I was doing, I thought, oh, well, let's delete London. But in fact, of course, I do the search, and there is London, Great Britain, and there is also London in Ontario. So if I'd have just not looked at what I got returned from my select statement, so if I'd just done deletes from city where name equals London, I would have deleted two records, London, England, and London, Ontario. And I might not have known anything about London, Ontario, unless I'd looked in the database. So it's always, can't emphasize this more enough, it's always really important that you look at the data and make sure you're doing what you think you're doing. Most mistakes come through just thinking you're sure that you know what you're doing or what the computer is doing. Okay, so that's just to show the record that's actually deleted. We run the select statement again, we get no returns, we get an empty table return. Okay, we want to put it back. Well, we can use an insert. We use the insert command to insert the data back in again. Insert into city, the order of the fields that we're going to insert. In this case, the same order as they are in the table, but it doesn't need to be that. And then we put values, and the values that we want to enter into those respective fields. So this is just repeating the information that I just deleted, basically. Re-entering the record. That's fine. We re-enter the record. We do our up. Okay, I didn't show you it, but it added the record in again. Can't remember whether it showed it on. Okay, now the population of Dundee has grown. So we don't want to delete the record and reinsert a record. We just want to update the record, existing record. So we can do, okay, now. So in this case, we use the update command. We're updating the city table. We're going to set the population, just the population field, and we're going to set it to equal 147,700, which is slightly more than the previous number, where the name is Dundee. If we'd forgotten the where command, we would have updated every row in our city table. All the populations would have been updated. So before you press except on your delete, your insert commands, check you know what you're doing. And then we can just get the return. There we are. There's our new record with 1,400 in there. Sorry, with 147,700. Select into. Okay, sometimes you want to, rather than just get the results, you want to save them into a new table. So for example, here I want a table of UK cities because I'm only interested in the UK, I'm not interested in the rest of the world. So in this case, I can use the select into command to create a new table that the selection goes into. So select star, because I'm returning all fields, into UK cities, which will be my new table name. And UK cities will be in the public schema, just like everything else that doesn't have a schema defined on it. From city where country code equals GBR. And 81 rows, so presumably there's 81 cities in the UK database. And indeed, if we look here, there's our new table created, Cities UK, with its contents, which is only UK cities, unsurprisingly. Views. We can save queries in your SQL file. That's brilliant. That's dead handy. But you can also save queries in a database as a database object, and they're called views. Well, one of the ways of saving a query is called a view. There are other ways, which you'll see in a second. So a view is a saved query that can be used in exactly the same way as a table. So that rather than write out, here's a view. So this is the same thing as so previously on the select into, we created a new table that contained a copy of all the UK or GBR cities. In this case, we're creating a view, which is a saved command that gives us the same information. So we create the view UK city view, it's called, as select star from city where country code equals GBR. And then we can just, once we've created that view, we can just do select star from UK city view. The UK view is not a copy of the data, it is merely a saved query onto the data. And we can treat it just like any table. We can put it into a select query. We can do anything we like with it. Okay, so that's an alternative way of presenting UK data. Make a copy, make a view.
Why would you do that instead of just not cluttering or not creating more tables?
Yeah. Okay. Why use a view over? Why would you make a copy versus making a view? A copy requires duplication of the data, generally bad practice, but it reduces the amount of data in this case that you've got in your database. So if you're never going to use the rest of the world and speed is important, then making a copy may be the best solution. If you're just working at the UK today, but tomorrow or next year you might be working on France and maybe want to clean up the whole data, it might be better to use a view. It's horses for courses.
It's just about what the end product.
Yeah, what the end product you want to be. So for example, you know, if we were based in the UK and we were using UK stuff all the time, and we needed really quick responses, we'd maybe make a copy of that and use that. But if it's not a problem, you know, if speed of access is not a problem, then maybe we just use a view. So, you know, many ways to get the same thing. And you're, as developers, which is what you're to become or are becoming, that's kind of those design decisions that you have to make. Is it better to make a copy of the table or is it better to make a view? That's a design decision. Functions. Again, back to functions again. Functions are saved SQL queries to which parameters may be passed. So this is the difference between a function and a view. A view can never pass parameters to. It's just a saved, it's kind of, you know, frozen solid, a select statement. But functions are more than that. They allow you to save the query and pass those parameters in. Remember, for the left function, I was passing in the parameter 2 to just return the two left-hand characters. There are a lot of functions that I've said have been defined in the system that are freely available. Have a look on, you know, you just have to look under the functions in the Postgres help and they'll list all the functions out for you. But they can also be user defined, so you can write your own functions and define them in the database themselves. And functions, not only, they're written, generally the most common way to write functions in Postgres is to use what's called the PGSQL language, which is a little programming language that comes embedded within Postgres for doing, this is not a declarative language, this is a procedural language which allows you to do loops and things like that, but it's a very, very simple language. But you can also do things like call Python scripts, Perl, R. You're familiar with those languages? Python is a general programming language, uses a lot in geoprocessing. Perl is an old school scripting language, and R is a statistics language which comes with the open source R package, which I use quite a lot. It's great. It's a great language. So you can call programs written in these other languages from your function. So you can have the functionality actually outside of the database. What do they look like? They look something like this. This is defining a function. This function returns the population for an input country, or code. So you put in a 3-letter code and it gives you the population for that country. As you can see, getPop, we put in the text. The text is the parameter that we pass in. GetPopulation is the name of the function. The text is what we pass in. We're passing in some text, and we're going to return a number as an integer. Okay? The function, the select statement is that select statement, select population from country where code equals $1. $1 simply refers to the first argument passed into the function, and there's only one argument passed in, text. So what it does is it takes the text passed in, chucks it into that SQL query where the $1 is. So if I put in GBR, it should output the population of Great Britain. If I put in LLD, it should output the population of the Netherlands. Okay, it's another toy example, but the point being here is that you can pass in these parameters to functions, which you can't do to views. You're not expected to do you're not doing functions really as part of this course, but it's useful to know that that's where they are. Almost the end now. Users and permissions, yes, SQL supports lots of users, permissions, things like that. So we use the create user function to create a new user with a particular specified password. And we can do things like grant permissions to access different tables. So we can say this person can read to this table, but they can't write to it. They can read, but they can read write to this table, that sort of stuff. Okay, So we can put total control over all our users as to which tables they can access and what kind of access they can get to those tables. Theme that's run through here: one problem, many solutions. In programming in general, there are many solutions to every problem. It's just that some are better than others. That's the bottom line. And as a designer, you need to come up with a solution that meets your users' needs. It's efficient enough to meet those user needs within a specified time period. Now, this isn't going to be a problem for any of the data sets probably that you're going to be using at the moment, but it might turn out to be a problem, say, when you're doing your GeoWeb development in the second half. But if you do hit a problem with slow query, you've written a query and it turns out to be slow, and I've faced this myself in the past. I've written various queries which have taken me, well, first of all, I wrote one query, but the first time I wrote it, it worked, but it was taking 30 seconds to run. As part of a web application, that's pretty awful. All right, it was downloading data, it was packaging data for a download and doing things like that. So it was a sort of reasonably hefty function I was writing. But then I rewrote it, I knew this was not really, it worked, but so it was great for a sort of demonstrating to the people supplying the money that they should supply a bit more money, but it wasn't suitable for a release application. So I rewrote the function and probably increased its speed by 30, 40 times. So we're talking a second instead of 30 seconds to get a response. So a major change in performance by rewriting a particular query and how it was done. Now, the simplest thing to do when looking at slow queries is simply compare the query time at the bottom of SQL and see how many microseconds it's taken to see whether you're any quicker than your previous, to the last. So if you've got two alternative queries, you just run them and see which one's faster. There is some variation though on things like network traffic. If you're using a server that's being used by other people, how many other people are using that server. So it's a good idea. I get a different figure every time you run a query, even if it's just locally on the device. So run it 4 or 5 times and see what the variation is. If you want to go deeper, then you can use, there's a command called explain that you run on a query, and that gives you some background on how the database query manager is actually undertaking that query. So the query manager is the part of the database management software that decides how to undertake a query. And it'll look at the query and it'll decide, I'm going to do this, then I'm going to do that, then I'm going to do the next thing to answer this query. And it makes, a pretty good guess. But humans are sometimes better than computers, and just like computers are sometimes better at humans than this kind of stuff. So it may be that a good database administrator can actually come up with a better query plan to answer a query than the database software itself. So an experienced database manager can actually override how a particular query is undertaken by the software to hopefully fine-tune it. I've never had to do this, but that's the kind of thing that the explain command returns. This is the more complicated in select function. So it's giving me the sequence of how that query is answered by the database system, whether it's doing a filter, whether it's doing a sequential scan on a table to get all the results, etc., whether it's using indices or not. You could force it to use it. We haven't really dealt with indexes a great deal, but sometimes indexes are there. We put them we include indexes to speed up the return of data. But in fact, sometimes putting an index will actually slow data retrieval because the index is worse than just sequentially scanning the table. So bear that in mind. There might be some tweaks you might find. If you've got a really bad problem, it might be worth looking in here and seeing trying to work out where the bottleneck is occurring. It might help increase the speed, the efficiency of your program. Okay, that's all you hopefully will ever need to know about SQL, apart from spatial extensions, of course, which is what we'll have after the break. Any questions? Nah. Yep, yeah.
Apart from your comment slides, is there any other functions like
Yeah. Well, okay, yeah, okay, referencing. Postgres help pages. I just type in, Google is my savior. Type in Postgres, and then hopefully you know what you want to do, or you have a verbal description about what you want to do. There are lots of online tutorials and things, mostly for MySQL, because that's the more widely used one, but they're almost the same in many ways, so just your standard SQL help can help. I have, let's think, for Postgres, I have one called SQL Cookbook on my, which has lots of exciting recipes for doing exciting SQL, but it's probably overkill for what you want to do. Yeah. There's one called SQL for Dummies, which is a very good one. Sorry? Yeah, SQL for Dummies. Is it SQL for Dummies or SQL? I can go down, I'll bring the ones up that I've got, actually. I'll go down and get them, and then you can have a look, and I can show you which ones I like or whatever. But I get 90% of my answers by an internet search. I occasionally go to these books for recipes, for more complicated things. How do I do this? When we get onto the Postgres extension, there's a Postgres in Action book. I'll go down and I'll bring one, and you can have a little look at what I've got for my shelf. Yep.
When we get to our assignments or essays and those things, if we use Google for help and things like that, do we reference it?
No, unless it's something special. I think is the bottom line to it. This is, you may be thinking, well, I've put a bit of extended reading up on the list, but this is not a module, frankly, where there's lots of background reading to do in this part of the module. I mean, you can read those books. That's a good idea, to read the chapters in the books, read this. But really that's probably about it. In the second half, when we're looking at more the interface development and things like volunteer geographic information, then will be much more sort of a few more scientific type papers to investigate. So, yeah.
Will we get marked down if we don't not marked down, but you would prefer to take it when we submit any code for assessment, that it be in kind of capital lowercase?
No, neatness gets you marks, yes.
Yeah.
I mean, neatness. I think I've written the criteria for so you'll get marked. If you'll get marked for getting the right answer, you'll get marks for having a nice layout and with good comments. You'll get marks for doing things efficiently, that kind of thing. But this is the kind of thing, when it comes to the actual SQL itself, there is an answer. You can get in theory, you can get 100% if you get all the answers right for the actual queries, but there's a lot more to it because we've got the design side of the assessment as well. Indeed, maybe next week I'll talk about the assessment and give a bit more background on the assessment. Okay, right, so just plough on. I'll go pop down, get those, bring up those few SQL books, and I can show you which ones I like, and you can have a look and see what suits.